Okay guys, today we're going to do composite functions. Composite functions is just putting one function into another function. The notation looks like this, and it's read as f of g of x. An alternate notation looks like this. The O in the middle stands for the word of, so it's not fog, it's f of g. Okay, so here we have two functions, f of x equals 2x, and g of x, which is equal to x plus 5. And we're going to make a composite function out of this. We're going to get f of g of x, which simply means we're going to put the g of x function into the f of x function. We start by writing the f of x function, 2, and then the parentheses where the x would be, because we're going to be replacing that x with the g of x function. So we're going to put x plus 5 in place of the x. We took the x and replaced it with x plus 5. Distributing the 2, we're going to get 2x plus 10 as our final answer. We could do it the other way too. We could take g of f of x. This time we'd be replacing the x in the g of x function with the f of x function. So where the x is located in g of x, we're going to put a set of parentheses plus the 5. And then in place of the parentheses, or inside the parentheses, we put the f of x function, which is 2x, giving us 2x plus 5 as our final answer. We can also use function notation as a type of shorthand. For instance, we could say, let's add f of x and g of x together. So that simply means we would take our x squared minus 3 and add it to our g of x function of 2x, and then simplifying that, we would get x squared plus 2x minus 3. Or I could use it to subtract functions. If we had g of x minus h of x, we would get 2x minus, and then we have our set of parentheses with x plus 1. We have to put our h of x function in parentheses because we're subtracting the entire function, not just the x value. So we get 2x minus the x minus 1, and simplifying that we get x minus 1. So let's get back to doing some composite functions. I'm sure you need a few more examples before you get it down completely. Let's try the function f of h of x. Again, we're going to start with the f of x function, putting a set of parentheses where h of x is then placed. We multiply that in, and we get 15x plus 3. Let's try another example. How about h of g of x? We start with our h of x, 5, and then where the x is, we put a set of parentheses, because we're going to be replacing that x with g of x, plus 1. And then in the set of parentheses, we put g of x, which is x minus 2. Multiplying in, we get 5x, and 5 times negative 2 is negative 10, plus 1 gives us negative 9. Now let's try something a little more complex. Let's do h of g of f of x. We're putting f of x into the g of x equation, and then we're putting that into the h of x. So we start small. We start with the g of f of x function. We put our set of parentheses. That's going to replace that x with f of x minus the 2. And inside the set of parentheses, we put our 3x because we're placing the f of x function into the g of x function. Then we replace that in a set of brackets because we've already used parentheses, so we have brackets. And now we're putting this function into the h of x function. So a 5 goes in front, plus 1 in the back, and then we multiply in, giving us 15x minus 10 plus 1, which gives us 15x minus 9. So in addition to composing or putting two functions together, we can take one function and decompose it into two functions. Let's look at the function f of x equals 3x plus 6. We're going to break this up into two separate functions, g of x and h of x. We start by distributing out a 3 from the original function, getting us 3 times x plus 2. The inside function, x plus 2, is going to be our g of x function. H of x function. So our x plus 2 is our h of x function. It's the inside function. Then we're going to create our g of x function. We're going to start with the 3, remove the x plus 2, working backwards, replacing it with the x, to get 3x. Notice we've taken the h of x function and put it into the g of x function, leaving us 3 times x plus 2. That would be g of h of x, which we also know as f of x. Because when we distribute that 3 in, we're back to our original function. So notice we decompose f of x into two functions of g of x and h of x. This should be a pretty easy section. We'll do some work on this in class tomorrow. Hope y'all had a good evening. See you then.